Good morning, everybody. Good morning, Sabry. Really looking forward to discussing this session with you.
Yes. So yeah, how's the weather in Tromsø?
Yeah. Oh, sorry. I should also say that I work at the University of Tromsø in the north. Looking forward to this course.
Okay. So I'll share my screen. Radovan, shall we go through the full schedule a little bit to see what's coming? Sorry.
Good idea to get an overview, and also a good if you show everybody how you arrive at the full schedule, so where people can find it.
Yes. So Radovan, if you get lost, the place that you should first land is our HackMD. So that is where all the links are. Do you have this link with you, Radovan?
I have the link of the HackMD, and on top of it, I find all the links, among them so there is the course page and there's the schedule, right?
Very good.
And the link to the HackMD is posted in the Zoom chat.
So I see this icebreaker question, whether I have experienced, whether we have experienced any instances where our laptop or the desktop was not enough, some big computation. Let's say if I have to add something to this, add an answer, what should I do first? Should I click the pencil button, or what should I do?
Yes, so there is either the pencil button. There might also be a button called edit. If you click on it, it switches to edit mode. We will use this document to ask questions, always at the bottom of the document. But now, for everybody to get used to this, we encourage you to go in and answer the icebreaker question. So here's how we went in, did a dash, and here you can type, and it will show up live, and we can all type together at the same time.
So I don't have to wait for someone to finish. I can just start typing, right?
Exactly. And
yes,
really the idea of this document is that we can ask questions in parallel, and we can answer them in parallel. So parallelization on multiple levels. And we can even have multiple answers to the same question.
So if I have a question, so I should be using one of these numbers. So if I don't have a number there, maybe I can have a new number and ask my question in these question sections, right? Or are these for me to answer, or is this the place where I answer for this question?
So here everybody can ask a question or take a new number. If all of these are already being typed in, open a new one. We have found it useful in previous workshops to number each question so that we can refer to earlier questions. Because sometimes we get the same question multiple times, and then we can refer to, like, look up, it has been already answered in question 17.
What if I accidentally delete something on this? Do I have to save it? Or?
We have version history of this, but be careful. I think everybody should be careful to not accidentally select a lot of text, because if I select a lot of text and then type something, it will replace the selection by whatever I type. Sometimes it happens to me, then the way out of it on my computer is Control-Z, so then I undo. So be careful about selecting too much with your mouse. But we encourage everybody to ask. You can also answer. It doesn't have to be only staff answering the questions. You can also help answering. And hopefully we all learn something new. The idea is that we will later publish this document on the website. So if you type, don't use any names, any usernames. We want this to be anonymous. And this will be a super useful document because these questions and the answers will be very valuable. There is no stupid question. If you think that the question is too simple to ask, it's probably a very, very good question. These are the best questions.
So Radovan, according to these answers, so if we take few of those just to get an entry point for this our discussion for the lesson. So let's say if I have my laptop and it in the first example, there was this file that I need to analyze, and it takes 1 hour to finish. So if it is one hour and it finishes and it is only one file, then you are fine with the laptop. But if you have many of those, now for the 450 as mentioned here, it will take 450 hours. So one thing would be keeping that connection alive, like, keeping the computer on, and whether you want to spend 450 hours to get your results. So do you see this as an example that could be transferred to HPC and finishes in a reasonable time?
Yes, these are great examples, because when we think about supercomputer, we may think that this is much faster than the laptop. But actually the key of a supercomputer, and we will discuss that and motivate it, the key of a cluster is not actually the speed, but it's the many. We have many of these computers in one, and we can run many of these 1-hour jobs at the same time. And we will show that we can schedule these, and then we can forget about them. They will start sometime, 2 a.m. in the morning. We don't need to watch it all the time. We can come back next day and check, did they finish or not? And we will learn all these things. So these are excellent use cases for the cluster.
So does this mean that I could start something and do some other work, and the cluster will do the processing for me, so I don't have to sit in front of it and look at it?
Precisely. So we will learn how to schedule, and then the cluster will start it at the right time. And then we will learn how can we check the status of a calculation, and how can we check whether it worked or not. We will also see problems and then learn how to troubleshoot these, because problems happen all the time.
Then what do you think about the time that we have to spend to learn these things? For example, how much do you think there's the return of learning these things is higher? So to motivate ourselves, if we sit through today and tomorrow, how much do you think we'll be able to achieve during that time? And do you see that our next course, for example, the advanced course, is needed before you achieving anything? Or do you see that just by end of these 2 days, we might be able to use what we learned and achieve something?
Yeah, my hope is, and I fully trust that we will all learn a lot of new things, including the staff. We all will learn things that we didn't know just by watching somebody else work. And in our presentation, we will emphasize, we will not go through slides. We will log into the cluster, we will work. And by me watching Sabry work, I will learn things that I didn't know that were possible, that I never tried. And is it time well spent and learning curve? I'm absolutely convinced. I think this is time very well spent to spend these 2.5 days, because often we spend many hours, many days working on these machines. And really important that we learn how to start jobs efficiently, how to troubleshoot. Then, as Sabry mentioned, end of the month, we have a second module where we take it to the next level. So then we will discuss how to efficiently, how to optimize memory, number of cores, parallelization, even more troubleshooting, and step by step we improve, and the return, hopefully we have a really good return from this.
And Radovan, I also see another usefulness of learning these things when it comes to exotic hardware. So Jørgen, for example, the person helping us with HackMD, for example, he's in this GPU team. So we have some very expensive hardware, some exotic hardware fixed in some of our clusters that might not be accessible in individual institutes. So learning to use these things will give you access to those exotic hardware as well. So before I jump into the lesson, Radovan, can you rephrase or tell me a little bit about the word parallel, because that will be using we'll be using a lot that word in this lesson. So maybe from one of these examples, what does parallel mean to you?
It can mean actually several things. It can, from at least answer 1 and 2, assuming that we want to do very many independent jobs, very many jobs, they are similar, but they don't depend on each other. They just want to be finished. So we can run them, they can run at the same time. So instead of running one after the other on one processor, I can use all these thousands of processors that are available, and they can run independently at the same time. There could also be use cases where we want, where these different processes have to communicate. So that's a different way of, so then there are different ways of parallelizing, making use of these many cores and processors that are available on the machine.
Okay, so we'll continue the discussion while the lesson is going on. So the schedule, Radovan, it looks like this. So we talk about this this remote login, sort of remind ourselves what we learned yesterday as well about the SSH and the login, and how to navigate inside after logging in to the cluster.
But wait a second, you are on this today. So today we have, that's where we are, day one.
Yes, thank you. So we'll be summarizing a little bit about what SSH was and logging in, and then we will log into a cluster, and then we'll see what are the challenges we have on working on a remote system. Then after a small break, we'll talk about something very interesting called a scheduler. So Radovan, after that, we have a break and some exercises, long exercises planned. But during this session, we might, we will most probably go into a sort of breakout room and try one of the examples in addition to this big exercise. How does that sound? Is that okay?
That sounds really good. And also let's clarify for everybody here, how should the learners best participate? And maybe attached to this question is, maybe people have noticed that you screen share a narrow screen, not so a portrait format, not a landscape format. So how maybe in the first session, so before we go to scheduling jobs, how should people best participate in this workshop?
Yes, so I would imagine, Radovan, that because there's portrait mode, there'll be enough real estate in your screen, enough space to open another terminal, even if you're in a not so big laptop. So that's one reason that this is, so you can not use full screen, but have the zoom on one side and have your terminal on the other side. So when I type something, and if you want to try it live, then you could do it as well. But during the exercises, you could also do this with the fellow learners and also the our colleagues who will be helping. Yes, does that clarify your question?
Yes, and one more clarification from me is that you might have noticed that we record this session, but we only record the main room. Later, when you are in exercise groups, in breakout rooms, nothing is recorded there. There we really encourage participants, share your screen, discuss with others, ask questions. Here in the main room, we recommend to keep your camera off, sound off, so then you make sure that you don't appear on any recording.
So tomorrow we'll learn more about software, how to access software and file transfers, and something very very tricky for most users, storage. So we'll start with the first lesson. So the first part we already discussed as part of our our main intro, why we, the instances we need HPC. I guess you're motivated. So here we have some examples from previous courses. At the end of this course, we will add some interesting comments that you have made in the HackMD as well to this. So thank you for your contribution. So you're already contributing to the material. Let's have a look at some basic concepts about the things we are going to talk. So let's take the keyboard. Let's take the laptop that many people are used to it. So we have a screen here, a display that you could see what's going on, and a keyboard to input things. But there are a lot of things inside this that make the processing, analysis, and everything possible. These things, if we oversimplify it, we could say there's a central processing unit, sort of like a processing brain, and a temporary memory that when you do calculations, you need to keep certain things temporarily in the memory and perform the analysis. And you have the keyboard to input, mainly as an example, and a display or to save the file for later usage. So we'll be using terms like central processing unit, memory, which will also use the term RAM, random access memory, and input methods. It's usually the keyboard that we use, or maybe the input itself could come from reading a file, and the output could be something you see, image that you save and look at later, or even save it on a disk. So these things, Radovan, when you want to run something, let's say you want to run a program on a laptop, what we do is, let's say there's a file program that analyzes file. You start the program, give the file as input, and wait for the output. So you don't worry about other users, because you are sort of the person on your laptop, and then your analysis is the analysis that going on. So this is your personal space, in contrast to the shared space that we'll be talking about a little later. And you don't really care about how much memory or the processing power or central processing units that you allocate, because if your program try to use more than what you have, it will probably crash, and then you will find out but in upfront, you don't normally ask the program to use this much of memory. So when that is not enough, we have these servers. Servers could look differently, but inside you will have sort of the same things inside as your laptop, but in a bigger and a more robust way. So this could be like towers or racks. Most of the servers we have at University of Oslo, for example, they look like just pizza boxes. There are no keyboards or monitors attached to them. They are just machines that you have to send inputs through the network. So that's what we were talking about yesterday a little bit about this SSH command. So these servers also have some limits. Radovan, do you use any servers, not HPC, for any analysis?
The other instance where I use servers are servers in the cloud. It's actually similar to a supercomputing cluster. It's actually also probably a pizza box like this that is somewhere, I don't know, Amsterdam or somewhere in the US. And I connect to it and I run some cloud computations or a web service. So this is another example where these things appear. So it's always, it's really a computer. It has more processors, sometimes more memory because there are more processors, and there is no keyboard, and then there is no really monitor. And we connect to it remotely. We connect via network. But the idea is really similar.
So do you mean, Radovan, that when we go to Google Cloud, Azure Cloud, Oracle Cloud, or any other cloud, the cloud itself actually have these things somewhere else so that we connect through the network and do your analysis?
Exactly. So it's the same setup. So somewhere there is some staff who goes in and checks and repairs these racks and replaces them and makes sure that all the network cables are in the right place.
So Radovan, there'll be a time that even these servers are not enough to perform your analysis. So there are certain tasks that might take 100 years, for example, in certain cases, that if you just use a server. And the solution is a computer farm that you recruit a lot of them, like about hundreds of thousands of computers, servers as before, to work as a single unit. So this single unit gives you like a higher potential of achieving this. It becomes more than the collection of parts when it works together. So you could read about these things a little bit, how it is sort of set up, but it would make more sense to understand, to get the understanding that we need for the rest of the lesson. I'm going to sort of compare it with the cloud, because you mentioned the cloud, the word cloud. So Radovan, all computers involved in a cluster are normally located in the same location, because the network cables could stretch so far, right? Connected with the local area network. So in Tromsø, I think you have visited the From setup. So is it in one room, the From, or is it in several rooms connected with the local area network?
So the compute is all in one hall, it's in one room. But then, as far as I understand, and so I'm more on the software side, not so much on the hardware side, but the storage is actually in a different room.
Okay, so then these computers are architecturally involved. Is there a simple way to explain me what architecture means, Radovan, here?
Maybe you need to explain it to me then.
Yes, so it's like if you run up certain programs, they should be compiled. They should be sort of made run in a certain way. That, let's say, you might heard of words like Intel, AMD, different manufacturers, and if you're going like really exotic like ARM, so those processors inside this these units, the central processing units, and how they communicate with memory, and how much sort of buffers they call it, how much things they can have temporarily in their processing memory are not the same. So the programs need to be optimized. So the reason they are architecturally similar is you don't care where it runs. So if a software runs on one machine, it's supposed to run on all of the machines in a similar way. So even the clocks are synchronized so that you get the same time. So it's same, same room means definitely, obviously same geographical location. And then they have access to common storage. So if you place a file, you could access it in the same way with the same path on any of the computers. For example, like if you have a file in your laptop, like desktop, my file, if you go to your office desktop, and if you're trying to find desktop my file, it would not be there. But in this setup, it's made identical. At the same time, I would mention like something like not confusing but interesting, is that some cloud providers, they have HPC system behind their cloud as well. So this is a comparison between a cloud and HPC system, but more to show how the HPC system is set up, how they work as a single unit, how they are close connected, how they are similar, how they are identical, and when you work on them, you don't have to think about where you are, like which compute node, that we'll mention that in a later, or which login node. So it's that similarity and that Radovan, do you know what I mean? Do you get this point?
Yes, absolutely. And I can add maybe 2 points to this difference between HPC and cloud. One difference is, for those of you who have tried any cloud computing, is that you typically pay for CPU cycles, or you pay for data transfer, but somebody actually visibly pays, you pay for it. Then when we are on a high performance computing cluster, it looks like we don't pay for it, because we get an allocation, and we will discuss how to, and we get a certain quota, and then we compute. And there is also a quota involved. It feels more virtual. for the very big projects, they actually do pay, but most of us here who will use the services, we will not pay any money for it. But somebody pays for it. I mean, it's a taxpayer. And I think it's good to remember that. So that's why it's also good to strive for efficient use, because these things do cost money. The other thing I wanted to mention, and it's the last bullet point in, if you scroll down a little bit on the note, is that now we have this really powerful system, lots of racks, and they are all interconnected, all this power. And now we have, I don't know, 2,000 people who want to use it, more or less at the same time. And now we need a scheduler, because otherwise it would be chaos. Otherwise it would be, there would be too many jobs or too few jobs. So we need a scheduler, and we will discuss that makes sure that we don't overuse the machine, but also that we don't underuse the machine. Ideally, we want the cluster to run 80–90% of its resource all the time. And ideally, none of us wants to wait too long for their job to start. So then we need to learn how do we design our jobs so that we don't wait too long, and that as much science can be done on the machine in an amount of time as possible.
Those are very good points, Radovan. Thank you. In the last 5–6 minutes, let's go back to that the thing I said in the beginning about you start a program and you wait for it, or you wait for it to crash, or you wait for it to finish, and then sort of think about it. In a shared resources, when Radovan said about this scheduler, it reminds me that you have to sort of ask a certain amount of resources for a certain time to be used, because of many people. It's a shared resource, many people are using it. So these resources you request are binding, in the sense that we'll talk about later today, that you should know roughly how long your analysis will take. So that's a challenge. In addition to that, there's a paradigm shift that for some people, double paradigm shift really. It is to working on the command line interface, as we saw a little yesterday, and then working in a distributed environment with this in a shared resource. So I could invite so do we? Yeah, so it's a navigation cluster. Is it going to be Jørn who's going to do next?
Jørn and Bjørn, Sabry.
Bjørn. So Jørn and Bjørn, is there anything that I forgot to mention in this lesson that is useful for your lesson we start in a moment?
I think you have covered most.
So where do you work, Bjørn?
Once more, Sabry.
Where do you work?
Where do I work?
Yeah.
I work at the NTNU HPC group.
Okay. So which cluster is there in NTNU? And is there like a big storage there as well?
It's Idun is the local cluster, and then it's Saga and Betsy, which is national systems.
Okay. So Radovan, shall we move on to the next lesson very slowly, if we have covered everything here?
Yes, we have covered. Well, I think I'm happy with what we have covered, but I want to encourage participants to ask questions. And we got one question already in. Please use this document. No question is too simple. We are watching this. Also, this setup that we have of co-teaching, we will always have two people, a little bit like two commentators on a sports event, asking each other a question, and the person not talking can then watch the HackMD, and we can relay some of these questions to voice. So please go ahead and ask. We have a number of staff here who can help answer either in writing or in voice or both.
So about this cloud question, really. So this distinguished can be sometimes not that clear cut. But usually when it comes to cloud, Radovan, we don't necessarily rely on geographically co-located identical computers with high bandwidth networking. So when you ask for a like a cloud instance, you might get one from Frankfurt and one from Tokyo, for example. So that's not guaranteed. So on HPC, when you do analysis, when you log into Saga and when you submit a job, your compute node 1 and compute node 2 are connected with very fast network and guaranteed to be in the same room. So that's one main thing that you could actually think of as a difference between a cloud and a HPC system, like in a general cloud, when you ask for instance. But in a cloud itself, even Google or like Oracle or even Azure, in the cloud itself, you could ask for HPC system. So that's another thing. Like when you ask for HPC system in the cloud, that's very expensive as well. So not to confuse that too.
And maybe I can add something which hopefully clarifies and hopefully doesn't confuse. Let's imagine that I'm a research group and I'm thinking, well, should I apply for a cloud instance or should I apply for NRIS high performance computing? And then for me, the question would be, if I need a lot of compute power only next week for 3 days, and then I don't need it for the rest of the year, it might be, I might go for the cloud. In the cloud can scale on a very short notice. I can get lots of compute power. However, if I want compute power for the next half a year or the next year, every now and then, I might be better off with high performance computing. There it will be way too expensive to get a cloud instance and then not use it for many weeks, and only use it every second week.
Yes, true. And another thing just came to my mind is the network that we have, this Uninet network within our universities. Let's say if you have a 100 terabyte file that you need for the analysis from University of Oslo or University of Bergen or some University of Tromsø, it will be feasible. It is possible to get that file into one of these clusters in a reasonable time. But if it is a cloud that's not in this network, for example, in another geographical location, it might take a long time for your file to reach that place. So it might be practically impossible to do that analysis. Yes. In addition to that, what Radovan said about runaway processes, like, if you start something and you forget about it, it might cost you a lot of money in cloud as well. Yes. Okay. So then, Bjørn, would you like to take over?
Yes.
Yeah, take over the screen, please. Dania, are we okay on time?
Yeah, I think we can manage it. And Jørn, are you here?
So then we're going to talk about how to work on a remote system. We already covered what's an Hpc system. We're going to dive a little bit more into detail about that. And how to connect to a remote system. We did that yesterday as well. And we're going to look at how the different nodes are on the HPC systems, that we have login nodes and computer nodes, and how these are, what's the distinction between them. Yes, so for getting access to Saga from a Betsy, you can apply at Sigma 2. So here's the link to that page, how to apply user account. When you log in through the internet from your laptop. And the typical use is SSH client if the cluster doesn't offer any other interface. some clusters have remote desktop, but the systems that we have in the national level in Norway, they are Ssh Login.
Bjørn, should we try it out if everyone has access?
Yes.
So do you want to show how you do it?
I can show.
Or should I? Yes.
Do you see my terminal now?
No, you only see the web page.
Only
So
see
it would be good, I think, for everyone now to open a console. If you've been in the course yesterday, you should already know how to, or we did it yesterday. So yeah, and then connect via SSH to either Saga or Betsy. Doesn't really matter for us.
Not Betsy, Saga.
Oh, okay.
Maybe you can do it. I have problems with sharing my terminal here, so if you could do it, Jørn.
Yeah, I can. Okay, sorry. So should be able to see my screen. Okay, I'm already on. Sorry. So sorry. This is my home computer. So I'm currently in. I connect like this. This is my username, and then at Saga sigma2.no, if I'm correct. Let's see. Okay. So it might be that instead of just like logging in like I did now, you asked for password, and if you have not done this, it's a bit confusing. If you type while typing the password, you can't see anything that you type. So you basically just have to type blindly. Once you hit enter, the password was either. So could you please try? Put a question in the HackMD to if everyone managed or if there's some problems, because we have people around that can help you if you have a problem. Okay. So so the syntax is you write SSH and then your username you've gotten in an email probably and then sigma saga.sigma.no or your username and then at fram.sigma2.no. Okay. So we have worked for a couple of people. You can also just write a question if you had problems. Because this is, if it doesn't work, then the rest will be a bit like only look and not do. Okay, I think that we can continue. Should I keep my screen share and you tell me what to do?
Oh, I can take over the screen again.
Because now we are hopefully all logged in. And now let's see where we are and what we can do and how it looks. And as a note, this is there will be no exercise at the end of this, so just you can type along if you want. It would be really good if the SSH connection to the servers work. Right. or show it. You can take over if you want.
Yeah. So now, so where are we when we are logged in? We can see what kind of host we are on. By the command host name. Here I got login to Saga.
We can't see your screen.
Can't see my screen. Okay.
At least for me, it looks like I'm sharing.
Yeah, you're sharing, Jørn.
Okay. Yes. Sorry about that.
No, probably Jørn can share what Bjørn is saying. Okay, now Bjørn is sharing. Yeah, that's great.
It's a bit small, I think, for me.
So is it a bit small? So now you see my terminal and no,
Well, we can see your terminal. It's a bit small, but I think it will work for now.
But now you don't see my web page, right?
Now we see your whole desktop.
Okay. So with the command host name, you see which login node you are logged on to, and there are several login nodes normally on a cluster. So what can happen if you come back to a cluster? If you yes. So that's if you use a terminal multiplexer, then it can be you have to notice which login node you're running that multiplexer on.
I think it can also be quite sometimes interesting to sometimes memorize which login is. And there are problems. Sometimes one of the login nodes is slow because someone did a mistake or there's a hardware problem. And then it's good to know if you want to write as a ticket. So you have questions. So how could you see where you are? Which command?
With the command pvd, present work directory, you see where you are, and I'm in my home directory.
Mm-hmm. But the home directory looks different than on a typical Unix. So it's not just /home, and then Bjørn Lindi, but instead it's cluster Bjørn Lindi. So this is one of the differences, I think, which might be, even if you're used to Linux PCs, might be something to be aware of.
And this tells me that I'm on a cluster work file system. So this is typically a shared file system, which is accessible from the login nodes and the computer nodes. So this is a global file system, which I can make use of in my calculations or simulations. So with the ls-a, I see my what's on my home top directory. So I have a lot of log files.
Yeah, Bjørn, may I ask you to increase the font, your terminal size and font size?
Is this better?
Yeah, one more probably. Yeah.
So if we look at what the drawing of the cluster, I'm now working on the login node, and we have then the worker compute nodes. That's those are not accessible from where I'm now. I need to run a batch script to make use of the worker compute nodes.
But what does it mean? What is the difference between a compute node and a login node?
A login node is typically used for editing, compiling, lighter work, while cluster worker nodes are used for the heavy tasks, for doing the actual simulations. So, and you get access to the worker nodes through the login nodes. So the login acts as a gateway.
So when I log in, when I connect the system, I end up on a login node. Yes. Or do I end up on a compute? Can I end up on a compute node by accident?
No, you can't. You have to take specific action to get onto a compute node.
And like, how are there? Is there only one login? No, I think we saw already some numbers there. So, and how many compute nodes are there?
Yes, we can write the command sinfo to see how many the distribution of compute nodes. So on Saga, this gives a very large output, but it tells us which compute nodes are accessible for being scheduling jobs. So
is it important for me to know like which numbers, because there's no like a ton of numbers? Do I have to know this for like in the future, or
you don't? The cluster nodes are, most of the cluster nodes are of equal size or equal have equal hardware architecture. So it doesn't matter where you run your job. So you don't specify specific nodes. You only specify the job, and then it's up to the system to run your job on the compute nodes that are available. But with the command sinfo, you can see that the state of several compute nodes. So we have that's here, that one is down, and so it's inaccessible, and these three nodes are drained. That means that they are on their way to being stopped, and allocated. That's a long list of compute nodes.
What does allocated mean?
That means that they are in use. And
also see there's a,
I'm not sure what mix but it means, but I think mix is kind of some are allocated and some are free.
So it looks like there's more than 300 nodes. So if I see the 173 plus 137, and yeah, you see there's a lot of like the numbers are just like labels for each node. So if you look at the C10, so for example, this is just one node out of many.
If we'll look at the output from sinfo on the web page, there we see that some are idle, and these are then available for batch jobs. But from the output in my terminal, there is none that are idle. So the whole system is allocated. The whole clusters are presently being used.
Should I take over and show a little bit around, like on show them the login nodes a bit?
Yes, you can do that.
So now I'm, as you see, I'm on the cluster. I'm on login 3. JD is my username, and I'm currently just logged in. So I start in my home directory, which in our case is cluster home, and then JD. I think most login nodes and compute nodes are principally quite similar, but there's, as you saw, there's I think 5 or 6 login nodes, but we have more than 100, we have a few hundred compute nodes. So let's just explore it a bit. I mean, we know now where we are, like where I start at least. I mean, if you try the same command, you will see that you are in your own home directory, but of course on a different name. I'm not sure if you've ever tried to see how much memory there is. This was too fast. But there is a file called proc.mem.info, and we can just with cat display the file and then look at the first few lines, 5 lines in this, and then we see there is a lot of memory on this node. This is just this one node, and I'm not good with seeing things. So this is megabyte. No, actually, Bjørn, can you count how much memory that is?
There is 792 gigabytes of memory.
So a lot. But still, the login nodes have quite a lot of power, but we should still be very careful about using them because everyone ends up on the same login nodes. And while if you start a job, it will get some compute node, one of the 300 we've seen, allocated, and your job will run there. The login nodes is shared by everyone, or at least the 5 login shared by everyone. So you do in the login nodes because they are not the whole system; they're only the gateway to the system. So there's a lot of memory, and we can also see. We can also try the same with, oh, not sure, proc CPU info. See, maybe also private thread. So there is, this is the CPU which is there. So it's not a particularly powerful by the, so if you like this, you might have a few gigahertz in your, but it has a lot of cores, and so I'm not sure now. Let's see what the whole file looks like. And then, where is it? Here's the number of CPU cores is 16. Bjørn, do you know, how many cores are, because now this looks like there are 16 CPU cores. Is there not more? I thought there would be a few more.
I'm not sure how many there is, but this could be that there's 16 cores per physical socket.
Also,
then there is several sockets.
Yeah. Also, I see here processor 63, so +1 because it starts with 0. So there's a lot of. Actually, if you don't want to look at how much memory or CPUs there is, you can also. I think this is good to know where to find it in our documentation. So let's see. Maybe you've already seen or used our documentation here, documentation.sigma2.no. I hope you can all see. If you look at this, this is information here. Might be a bit too much at the beginning. If you here look into the overview, we can see that overview over our machines. And then in this case, I want to have see, for example, how Saga is, and then you get some information. And you see here that we have 200 standard compute nodes, and with this configuration, 40 cores, and we have 100 with 52 cores, and then we have 8 login nodes. There's 256 cores, so there must have been 4 sockets, each with a CPU. Oh, to like know, it's also like you can also find the information on our documentation page. And I'm pretty sure you will use our documentation, or at least I hope you will use our documentation, because we hope it's helpful. Okay, let's go back. Okay, so the login node alone is a lot more powerful than my PC like I use here now. But the actual calculations will run on the computer. To get from the login to the compute nodes, we will later learn how to do that. This is by writing job scripts and basically writing a job script which describes what you want to do, and then handing this over to our scheduler, which is like a program which just then tries to like fit like all the jobs, like distributes them over all the compute nodes as efficiently as possible. There's also the possibility of having a live, like an interactive session, yeah, like you see mine like session now. But usually you write a script which describes what you do, and then you and it will run at some point in the near future. So maybe in 2 minutes, or maybe in, I don't know, a day if you need a lot of resources and the cluster is very busy. So you don't have to know which compute node you want to run as we will go through all the steps in the next coming sessions, I think today actually. One more thing which might be interesting to know is the file system. So what I'll go back here. Like usually your computer at home, you have a hard disk, and all this data you produce or you download is on this hard disk. Maybe you also connected somehow to some cloud storage or backup solution, but the majority of the stuff you do is on your hard disk. On our clusters, it's a bit more complicated because we have a shared storage, which is important because every compute node and the login nodes all should have access to the same information, so that if you put your data files for your analysis onto the server, you want to be that can access them. So we have this shared storage, and the shared storage is actually just its own server. It's like a really high bandwidth or high speed interconnect. So, and they're all coupled together. So you can see your home folder, like you saw the path to mine, or also your project space where you store stuff for your calculations. You can access all this from every single compute node and every login node. Yeah, so file systems have their challenges as well because they are shared. It also means if you have a lot of input output, like you read a lot of small files, for example, then other people, you share the resources with other people. But so important to know there's a shared storage. Not sure if there's any questions now. I think I answered the one.
Yeah, and I think if we can, it's time for a break, 10 minutes break.
Yes, exactly.
Are you finished, both
some...
of you? I think so.
Yeah, I think so. We can go to the break.
So we'll start up with the scheduler.
Yeah, after the break, we will
after
start.
the break.
Yeah, we will start at 15 minutes past 10, 10:15.
10:15.
Yeah, we'll have a break for 10 minutes, actually for 11 minutes. And please have some coffee and stretch your legs and hands and be back at 10:15. Thank you.
Ready?
So welcome back. And we have this question on HackMD. So how the speed of lecture so far, is it too slow or too fast or too confusing? Just add an O on this thing. Okay, and we will continue with scheduling jobs, and there will be exercise room, right, Sabry, during the this session?
Yes. So I'm Sorry that I might take the exercise a little bit earlier. So, but I'll give a very clear warning when I reach that point. But usually the normal. So if let's go back to the schedule a little bit. So if you are lost and don't know what we are doing now, this is the page that you should find. I think Dani has pasted this link on the email and also on the chat and everywhere. So come here, go to the course page. On the course page, we are on the scheduling lesson now. So in the course page, you have several lessons. On the day 1, we have finished these 2 already now, and we are in this scheduling. So if you click that, you will end up here. So we had a discussion about what this scheduler is a little bit, not so much, but the reason that we need it. As we saw slide a little bit, this is a shared resource. This is not your personal laptop. So there are many people who are waiting in order to use a shared resource. In order to do that, it's very important we have some sort of order going on. In this diagram that we have created, Bjørn, do you see this diagram well enough for me to explain? Bjørn?
Yes, I see it well.
Yes,
Okay.
yes. So, so in this, so Bjørn, do you remember a time that you went to like a very popular restaurant, and there was a queue because it was booked? Have you experienced that in your life, or
Yes,
are you
I
not a restaurant
experienced that.
person? Mm-hmm. So why do you think it is there's a queue in very popular restaurants?
Why?
Yeah, why?
Yes, so the restaurant can make good allocations or the right allocation for its customers.
Mm. Yes. And another thing would be popular restaurants are well, they're sought after. Like everybody want to dine there. So if there's something very useful, people, if very tasty meal, for example, they will go there. So more the popular places, the places offer a good service. You could expect some queue because there are more people who want to use it than the resources. So here, I would like to focus on certain words that we already mentioned. The scheduler. So there's this person in the gate, and these are the users that us. We are trying to run something on the HPC system, and we are going to go inside and run. So we are going to schedule a job in HPC language. For this, there's this blue person here who is a queue manager. So queue manager, we could think of it as a bouncer or a broker or a person there who knows a lot about the cluster itself, like what's behind the door, how busy it is, how many people can sit at the same time, and how many free seats are there, that sort of information. But the users do not have that. They could get the information, but they are not in control of those things, and they might not know like how long it would take to get a table. But this information is there with the scheduler. So what the scheduler do, in this case, I'll introduce another term, Slurm. So this scheduler in our system is called Slurm. Do you know any other schedulers, Bjørn?
Yes, you have PBS and load leveler. Yeah, there are several.
Yes, so this is not the only one, but this is the most popular, and this is the one we used in Saga, Betsy, Fox, and many Udun as well, I think. So we are going to sort of learn, but if you learn the concepts of Slurm, you're more or less okay to sort of learn other schedulers as well. But a job script that is customized for Slurm will not work exactly as it is on a PBS, or a PBS script that you borrowed from a colleague who works somewhere else would not directly work on our system. So you have to keep in mind. So scheduler, Slurm. So what happens is when the people come, we have several scenarios possible. So there could be a table that is fully booked. So we see this user who's occupying the seat, and we call it a busy compute node. So if you remember that the screen that Jørn or Bjørn shown before, this is an allocated node, means somebody is using it, and this whole node is busy. So this node, we could think of it as a node with 5 cores, like the processing unit that we saw in the beginning. So this, but usually in our system we have 16. I think it's 40 or 20 on one socket on Saga, for example. Our colleagues, please paste a link on HackMD where it explains how many, so the core count of our clusters, so people can read about it. And there could be idle nodes. So this is an idle node with 6 cores that is not being used. So the scheduler, with that information in mind, can send 6 people in and they could start running the jobs. And this is another type of term that we will see. It's reserved. That means it's free, but it is been scheduled for a particular set of people. For example, let's say during the COVID pandemic, there was a group who was analyzing COVID data. So there were some machines reserved for them. So only they can come. During this course, Marios and the Sigma 2 staff, they have the user management staff, they have arranged certain nodes. So the course participant could go with a higher priority. So they don't have to, if that table is there, they could just go bypassing the queue. And there could be mixed nodes with, some are busy, and then some are available, and some are allocated. So the allocated means that somebody is on their way. So you cannot use it until. So if I rephrase that, so that a chair is free, but somebody is on their way. So you're not supposed to allocate somebody else or your seats in that chair. Does that explain, Bjørn, or is there anything else that you want to add?
Well, I think you covered most.
Yes. So Bjørn, because we are working with this scheduler, so we let's say if we want to run an analysis, we can't just start our job and then sort of, how can I say, the data files and specifying the extra things that you need for the job. For example, the input data, the parameters, the software you need. Those things need to be informed to the scheduler as well. So what you do is you package everything in one file. You tell the scheduler that I need this much of resources and I need this software. I need to run this software with this input file and place my output file in this specific place. That means you write down everything, the whole life cycle in a file and give it to the scheduler, and the scheduler makes sure that it gets that resources it requires, and it does not use more resources than it was asked, and it gets the software that's needed. It's loaded, the software runs, the input file is accessed, the output file is written, and then the job is ended, and then the results are given to the user. So while the job is running, while the processing happens, all communication that you need to do with your analysis is done via the scheduler and scheduler commands. For this, I think we learned a little bit about the terminal text editor yesterday. We used Nano, and for this today's example as well, we shall use Nano. Not because it's the most powerful one, but it is the most easiest to get started with. Beyond from yesterday's summary and your personal experience, why do we need a text editor? Why can't we use like a graphical user interface to generate our files? Do you see any specific reasons for that?
I think you showed it very clearly yesterday when you created a file with a graphical editor. It adds a lot of metadata which the batch system doesn't understand. So so we need a pure text file with the different commands, and that's why we will use a text editor.
Yes. So what we see and what the computer sees should be exactly same. So what I'm going to do is I'm going to log into Saga. So for this lesson, it's better that you look at what I'm doing and sort of get a understanding of the procedure, like without you typing in. The reason is that because your first job, and if this is the first time on your HPC system, that you might miss certain things. So it's better to see that what I'm doing, I will be purposefully doing some mistakes beyond. So can you help me to point that out, or purposefully or mistakenly doing mistakes, that pitfalls, for example. So I want you to sort of pay extra attention and sort of see whether I'm doing the correct thing and the way I'm supposed to do. Is that okay?
I will.
Yes. So we log into the SSH, the Saga first. The program I'm going to use is called SSH Secure Shell. I'm going to establish secure connection over the internet. So I'm on my laptop. Before that, I'll ask host name that we saw before to make sure that is my laptop. Then I'm typing my username. So when you are doing your work, you should type your username, saga.sigma2.no. Right? So this is the address of the server. This is my username separated by @sign. And when you press enter, you'll be asked for a password. As Jørn mentioned before, you will not see what you type. I have to stop talking and type my password. Otherwise, I can't concentrate on that. Yes. So I type my password. As you see, there's nothing shown here until you press enter. Then you enter here, host name again, to make sure that. So I'm going to clear my screen so I can start from the top. Shall we make a folder for this? That will be easier. I will make a folder 04052022. So we learned this command yesterday, make dir. This will create a folder named 0405-022 without any spaces on my home directory. And I can see that it is created. ls list the file, list the directory, and it will show you that it was created by me, by this user and this user group. This is very important for the lesson later on coming up with Radovan and Thomas. They will mention more about this, what this _g means and how it affects your quota. I'm going to go inside this folder and I'm going to do my first job. Okay, beyond then, so I think I just overstepped a little bit. Do you want to show this first job?
No, just continue. I think you're doing fine.
Okay, so let me know if I do something wrong. So then I'm going to create a file. The teaching material, if you see, it starts with nano, but to show what's been typed in the file, we use the command cat to display it. So this means I use the editor nano to open this file and include this content. So let's do it and see. ls, as Nikolai yesterday reminded, that it's very important to see what's already there before we go into that, dive into details. Oh, sorry, and nano example job.sh. So we don't have to like call it sh. It doesn't mean it's all for humans, but it's very important, Bjørn, that we don't use any spaces. Do you agree on that?
Yes, that's right.
Mm-hmm. And after you open the, so I'll go out, Control X to go out. I'll show you again. So open the file with the nano program nano, and the argument is the file name. You open it, and the first line is a sort of a standard line. We call it the shebang with bin bash, which means that this script, this is written in a bash language. So this gives the indication of to the computer and the operating system. Sorry, not the interpreter, rather the part of the computer that understands this script. It starts with bash. For example, you could say like a language. So it'll use that syntax. Then I'm going to echo. So this dash my n on echo, I actually forgot what it means. Why do we need that n? One of our colleagues, can you please mention that on the HackMD? Why do I need this n here? And then it might be have to do something with lines or something. And then what
it means do not output trailing new line.
Thank you, Bjørn. Thank you. Then I'm not going to really run any jobs. But if you remember the command I typed before, host name. So I'm going to print the host name here. So it's a very simple script.
I think you should leave a space between your after on, because if you run it like this now, the host name will be, there will be no space between the host name and the word on.
Here, so there's no new line.
That's right.
Thank you. Yes. And then do you remember the shortcut to save this file, Bjørn?
Control X.
Okay. It's asking that it is something modified. Should I do anything or just press yes?
Press yes.
I press the keyboard Y. And it's asking whether it should use the same file, overwrite it. Should I press enter?
Yes.
So what it did was it used this file name to create a file. So view what I did, I'm going to do a cat. So this is what's inside the file. Another thing that I see that may be missing in the material a little bit as well. Okay, but we can do it like this. Now we are in the compute node, where we are not supposed to run jobs, but we could do small tests. We could download, upload files, and we can do certain things. But in order to understand this process of scheduling, I'm going to run that file on this computer, on this login node itself, which you are not supposed to do for a large analysis. So there's no schedule involved, no slurm involved, just you and the computer. To show this a little bit, because this is not an executable file as Jørn showed before, I'm going to make this executable, which I see is missing in the teaching material, that we have to be a little bit careful. Or if you can, somebody can edit that, that will be nice. So then I see that this is an executable file with an X here. Then I'm going to execute this. What would it print? What do you think it will print, Bjørn?
It will print this script is running on login 1.
Login 1, yeah. So the script is login on. So as Bjørn mentioned, if that had not used the space here, it would start L here itself. So there's no schedule. This is how you would normally do it on your laptop. So Bjørn, if everybody try to do this, their jobs, what would happen?
That they will get the same output as you. This is a very lightweight job, so it's not a problem for the login node to handle it.
But if everybody do the analysis like this without the scheduler that we're going to explain later, what would be the outcome?
Then if this was a more heavy job, or more heavy analysis, we would the login node would stop working more or less because of the use of resources.
Yes. So the other users will have trouble logging in even, and the actual processing computers will be like idle. They'll be like free, consuming electricity and not doing anything, but while this chokes.
So it's like starting to eat in the queue in your restaurant.
Yes. On the doorway, blocking the doorway and start eating. Yes, just lay your carpet and start eating on the doorway. So then there's another concept that we're going to talk about now a little bit, is that if in order to use this cluster, you need a bank account, not in a sense with money and real banks, like the handling with the money, but a project account. Do you know what a project's account means, Bjørn? What does that mean?
Yes, it's a bank account. You have CPU hours as instead of money, but it's very close to money because the CPU hour, you can put a money, say that a CPU hour has a value.
So when I type the word, the projects, the command projects. So when you before you start any SPAT job, you should understand the projects. Can some of our colleagues remind me which one is the project account? Was it 9736?
No, Sabry, and then 9989. Okay.
9989. Okay. So this is the one you should use for the course. So you should let the Sigma 2 people know that for your job, how are you going to play for it. So when you apply for a project, you'll get some project hours. So I have few here as support staff and some of other users I do, but I'm going to use this one here. And the project name will be different in your terminal. So you will not see the same thing, but I would say that you will see at least this one in your accounts. Then the same thing you did before, this thing, I'm running on login node. In order to ask the scheduler to do it, you have to use the command S batch and remove this part. So I'm going to, let's say, reduce the font a little bit. Is it still readable or should I make it bigger?
It's readable.
It's readable, yes, because I need some space for this. Then in between, this is the SPAT. This is how you, Bjørn, kindly, politely ask the scheduler, can you take this script I wrote and run it on a compute node and give me the results instead of running it on the login node. For that, I need to say how am I going to pay for it. I'm going to say account and NN9989 is the account I'm going to pay for. And there are some.
You need a K at the end.
Thank you. Yes. And then we have to tell at least how long I want to occupy the cluster for this and how much memory I need. That is, those are the minimum things. Other defaults are set on our cluster. So this could be different in different clusters. So a cluster in Sweden or like in Germany, they would have different default values that you had to mention. So I'm informing that I need only very small amount of memory, and I'm going to ask for time 1 minute. So again, I'm running out of my terminal. So one option is for me to reduce the will that confuse? Okay, let me do it anyway. I'm going to use a hash in front to tell the terminal that not to execute it. Just leave it as it is. And I'm going to reduce my terminal a little bit, not the terminal, the prompt. So I will have a little bit more space. Yes, if what I'm going to do is confusing, then I should ask in the HackMD and they will help what I'm doing here. So I have more space to show you on my terminal. So I'm going to remove the hash in the front to tell the terminal that I'm going to execute again. So here I'm going to ask 1 minute, and I'm going to have the job. Again, I'm going to show the ls to see what's there. So it's only the job. Then I'm going to give that to the scheduler. Then when you give that to the scheduler, Bjørn, you get a job ID. So this job ID is important when you contact us for support, for example. Do you agree, Bjørn, about that? So it'll be easier for us to sort of see what's going on.
Yes, we can't do anything without the job ID, because there are thousands of jobs, and if we need to find out what's happened to a job, then the job ID is the first. It's essential information for us.
Yes. Let me check the time of the schedule a little bit. 10:55. Okay. So then, so when this is running, so there's a command called sq to see your job status. But I would think that this job is already finished. But let's see for the reason for. So this is the command. This means list all the jobs for my username. But there are no jobs. I was a little late. But I will show you again later on how to sort of run a larger job and see. Then I will do ls minus lh to see the files. And I see another file, Bjørn. What is this?
This is the output from your batch job.
Yes. Shall we see what's inside?
Yes.
Yeah, I'll use the command less. And you see, Bjørn, the job ID is there, right? So by default, so it will be easy if you have many jobs to run. Okay, so this is what it printed. The script is running on C560. What does C560 mean, Bjørn?
That's compute node C560.
Okay, so probably it's like the rack 50 and the compute node 60.
In that rack.
Yeah, in that rack. And there are some other details. You might go into a little more detail on some of them later on. So this is the log file. So when you open with less Q, letter Q on the keyboard to come out. So that job is finished. So it ran. So it didn't print login node. So that is how it was sent to the compute node instead of login in. Bjørn, what do you think about that? Are we all right?
Yeah.
So then what happens is I couldn't show you the queue because it was too fast. The cluster finished it. The scheduler scheduled it very fast because I told you we had some allocated nodes as the course participants. And that is one other reason that I asked people not to follow. So I'll have like full priority access. I don't have to wait in any queue, just go and execute it in that account. Yes. So that's, yes. So then what we do is, so these things, let's you see these things, it's not that convenient beyond to write these things on the terminal when you submit this. It's better that if we have everything inside this, most of the things inside this job. Do you agree, or how is your practice?
Yes, I keep all the SBatch options in the file. So I just can then write sbatch example job.shell, and it's and then I don't have to remember everything from time to time, since it's in the file anyway.
Okay. So what I do is I'll open the file again, example, and then give me a second. Okay. So I'm going to open the file again, and I'm going to try to include these things more or less with the script itself. So when I opened with Nano, it opened the previous file. So Bjørn, there are certain instructions that the Slurm, the queue manager, would read as instructions to itself. For example, if I mention S batch, Slurm would know that this is something the user is trying to tell me. So here I'm going to say account, the same thing I typed before on the terminal. And can you remind me the project account? NN9
89K.
89K. And then another instruction, S batch. You could also mix this as like you mention some of it here in the job script, or some of it is in the terminal. So memory, the same thing I did, same amount I mentioned before, and then S batch, and time. So why is this time important, Bjørn? Why do we have to give us a sort of reasonable time?
Yes, that time is important, so the scheduler can find the time slot for you.
Yes.
So and if you, like we were running just for a minute, and then if there's resources that are available for more than a minute, then the job can run fast.
Job can be scheduled fast, maybe, if I rephrase it.
Yes.
Yes. So there's a fair allocation going on. So if you are asked for 10 minutes, the Slurm do not know how long your job exactly would take. It trusts your judgment, and then it will queue everybody else according to that. So so the scheduler would think that, oh, this job is 10 minutes. Okay, there's another job, it is 10 minutes. So it will schedule 10 minutes after. And also, if you ask for 3 days, for example, then it would say, okay, this job is 3 days. And if a job comes again with 10 minutes, it will schedule the 10-minute jobs before the 3 days, saying because now it will finish quickly. So the person going to wait 3 days could wait a little bit, but the person who needs only 10 minutes should not wait 3 days. That sort of fair allocation. So if you ask more time than you need, you might have to wait in the queue longer. So you need to have some understanding. And Bjørn, here, I'm going to use the command.
So now we are asked for 10 minutes.
Yes.
And that's your purpose?
That's my purpose. But my job, I'm saying just to sleep for 60 minutes. That means pretending that some analysis is going for
60 seconds, you mean?
60 seconds, yes, 60 seconds. So I'm asking for 10 minutes, but I will perform analysis only for 60 minutes. Then the scheduler will allocate me my resources according to my 10 minutes request. But after 60 seconds, it will finish it off and it will reimburse the money that I paid for the 10 minutes. But what will happen if I run 6,000, a job that takes 6,000 seconds, but ask for 10 minutes? What would happen, Bjørn?
Then you're asking, then your job will be cancelled by the batch system because you're using far much more time than you have asked for.
Correct. So it's binding. If you ask for 10 minutes, your job will be cancelled after 10 minutes and you will lose the amount you paid for the 10 minutes. So you lose some money here, the CPU hours more or less, and your job will be not completed. So the compromise you need to make. I think our advanced course would sort of give more indication of about this time. So then I'm going to save this file with Control-O this time without doing the Control-X exit, and say yes to save it, and Control-X. Now I'm going to use the ls command to see that there's already one batch there. So this time when I say s batch, okay, just for the sake of showing these things, I'm going to let's say do something wrong here. Maybe remove h here. Control X. Let's see whether S batch would figure it out, because I just want to simulate somebody mistyping something. So here it says it has actually detected submission failed, time limit specified required. So S batch is looking for the time limit, but because I misspelled it, it didn't read it as a instruction. So when you're going back to the exercises, you should read these messages, Bjørn. Don't you agree that, rather than just trying more things, if you read it carefully, Slurm tells you a lot of things that you could actually fix. Have you encountered? More thoroughly, you get more detail on how to fix it. Can you hear me?
You froze, so I didn't catch what you said.
Yes, sorry about it. Maybe some internet problem. So what I said was reading the error message is important to understand what to fix.
That's right.
Yes. Also in the Slurm file, look for the errors. Just read it. Like it might be overwhelming at some point, but reading it would help, like to understand what's going on. And then I'm going to fix that spellings mistake here with patch. Control-O, Control-X. Then I'm going to submit again. Then now I'm going to ask SQ, what are the jobs for my user? If you don't use the user, you will see the jobs for everybody. And then you could discuss a little bit on the HackMD and on the when you're doing the exercises, that what does this status means. Pending status means you are in the queue. You have not been allocated anything yet. R means running. And this could also mean some error messages as well that we might list. I have to check. Our colleagues, can you please check whether we have the allocation not available, QoS not available, and other statuses. They might have some list. Otherwise, we'll pull it out from SPatch. So this is still running. So this will run for 1 minute. I can use the command watch to just see how it is running. And that command watch would sort of, without me typing SQ all the time, it will watch for 1 minute. So it will run for one. Oh, sorry. Bjørn, I think I have done something wrong. Can you guess what it was?
Yeah, you have sleep for 6,000 seconds or something.
Yes. So if I run this job, it will not finish before our course in another 10 years.
So the job will be cancelled. But I suppose that was what you wanted to show.
Yeah. How do I cancel it, Bjørn, if I do something wrong?
S cancel and the job ID.
S cancel. And this ID, you mean the 55 something?
Yes.
Yeah. Oh, now its job is gone. Let's see the error message. So it has created a log. Let's see that one. 3. Okay, so it says it's been cancelled. So that is the error there. Q to come out, and I'm going to modify the example and run it for 1 minute. Bjørn, you are supposed to take care that I don't do this mistake, or did you let it do the mistake so we can show the cancel? Was
Yeah,
that
well,
your
that
intention?
was my intention. Yes.
Oh, yes, of course. Oh, I did something very wrong. I'm very sorry. I opened a different editor because of my muscle memory. Okay, let's fix that. I opened another editor that I was not supposed to sort of show off. Nano? Control O, Control X, then Dispatch. Now, Dania, we are preparing for the break now because I think I ran a little bit late, so I was not, that exercise I was planning did not happen. So we'll run that and the SQ, and it'll still pending. Let's do the watch. And from when you're in the watch, you can see the status changing from run to pending to run, for example. And after we come from so I think you're planning a break now, Dania, if I'm correct.
Yes, Sabry, but you
Yes.
can take like 10 or 6 more minutes. Like we can have a break at 11 or 5 or 11.
No, like we will take the break now.
Okay.
But after the break, we should come back here, not
Yes.
go to the exercise as mentioned directly.
Yes.
Right. Let's finish this job as it is, and let's see where Bjørn has any other wisdom that he would like to share with us about this. Do you know about this partition, the name, user? What does this columns stands for?
Yes, the partition, you see the job ID, that was what Dispatch reported when we submitted the job. Partition is queue name, so you can have different queues. And name is the name of the job, and user, that's you. And then you have the state, which was, now it's finished, so now it's not there anymore. The time shows the wall time that the job has used, and the number of nodes, and the actual node list.
Yes. So to get out of this is hold the control key and press this C, and see the. So I'm going to sort the log files according to the time it was created. So it's easier for me to check what was last created. Less slam 317. Yeah. Job script is running on C559. Yes. So earlier it was, what was the, okay, let's grep for that. What was head? First 3 lines maybe, yes. First 3 lines of all the log files. This means print me the first 3 lines of the first log file. So this was running on compute node, and this was running on 59. This was in 60. So it was different compute nodes. It was allocated according to the resources available at that point. So Bjørn, is there anything else to add here?
I think you have covered most.
Okay. So when the after the break, we'll start with the sort of changing the name. Maybe Bjørn can explain that. And Dania, you may take my screen now. And
Yeah, that Sabry, before that, can I ask you a question?
Yes.
So we have this reserved note for this course. So are you going to explain it after the break, and so that people can use it during the breakout room if they are going to try several jobs, and later today afternoon after this lecture sessions today?
Okay. Remind me if I forget again.
Yeah.
So after the break. Yes.
Okay.
Thank you.
Yeah, thank you. Yeah, we'll have a 10 minutes break and we will be back after 10 minutes past 11. Okay, break until 11:10. Thank you. Bjørn?
Yes.
Okay, so you are going to take over?
Yeah, I'm sharing the exercise now.
Okay, so could you explain it?
Yeah, I will.
Yeah, thank you.
So now it's your turn to create jobs. So you can do, as an exercise, do what Sabry have done, showed you, and create a job, and then submit it to the batch system and see it run. And then as an extra step, you could then change the output file to something else. So and you use the manual pages for Slurm to find out how you can modify the Slurm output. So that will be the exercise.
So they are supposed to use the project, training project, NN9989.
Yes.
And there will be a reservation. Could you point out how to ask for use the reservation when you run the job? Because we have the reservation so that our participants don't stay on the queue for a long time. They can get done with the job soon. So 3 nodes are reserved for this particular course.
Do you know the name of the reservation?
It's a project reservation.
It's a project reservation. Then
Yeah, just
isn't it then enough with just the project number?
Yeah, let me find.
I think.
Yeah.
So just use the project number and then 9989K. So then it should work.
Yeah. I think you should do S batch dash reservation is equal to NN9989K.
Okay.
So maybe we can post it on HackMD.
I'm unsure of that. I'm
Yeah,
not sure reservation
I will put a note on HackMD how to do that. So exercise expert helpers can get have a note on that. And there are 6 breakout rooms open for all of you to join, and you can self-assign to the breakout rooms.